Hi everybody and welcome. Today we're going to be talking about solving for the zeros or intercepts of a quadratic function. So your goal after watching this video will be able to basically take the factoring that we did last time and actually get some x equals answers. So what does this apply to? What are we talking about? Why does it matter? So to start off, if you think about the quadratic functions that we've been looking at, if we put them on a graph, they look something, maybe it looks like this. You have the motion like so. And we know how to solve for the y-intercept. That's just like our b value. That's the constant. But something that we haven't done yet is solving for these x-intercepts. So where it crosses the x-axis. And these are actually extremely powerful points because it kind of gives us the idea of where something hits the ground. So let's say, for instance, you're throwing a ball. We'll use your arm, goes up, goes up, goes up, and starts coming down, and then boom, hits the ground right here. So you can tell based off of the speed, trajectory, arc, all of those things, the exact point where this is going to hit something. And this is particularly useful in quite a few examples. Let's say instead of throwing a ball, maybe you're shooting a basketball and you want it to go into the hoop. Or maybe if you're famous baseball pitcher, Hall of Famer Randy Johnson, you threw a baseball and you're trying to prove to PETA that when you threw it and before it hit home plate, it hit a bird, that it wasn't on purpose, that you were just throwing a normal pitch. So that's a true story. I actually asked about it in class, if you remember. So that's kind of the idea here, is that we're able to solve for a point in this quadratic motion. So a couple of things and a couple of rules that allow us to do this. Something called the zero product property. And basically what this says is anything times 0 is 0. Doesn't matter what it is. You could have $1 million, multiply it by 0, it's still just going to be 0. You could have y and multiply it by 0, and it just is 0. So again, anything times 0 equals 0. Fill in the blank, doesn't matter, it equals 0. Well, that includes expressions. So if you have something like, x plus 2 times 0, that still equals 0. And this helps us today because when we're going through and doing some factoring, so let's say we had a factored example like yesterday, so x plus 1 times x plus 2. If we set this equal to 0, if any of these equals 0, that means that the other one, by this rule, is going to make it true. It doesn't matter what the value is, as long as one of them is 0, the whole thing equals 0. So we can kind of split this out into a couple of pieces here, but basically the idea is that we set each of our terms individually equal to 0, and then we can go through and solve. And it's going to give us two answers. So 1, and then 2. And if you look at it on the graph, again, something like this, maybe it goes up this time, it's going to cross at -2 and -1. So those are what those two answers mean to us. So again, going through our examples today, we are factoring, we are finding what the two parentheses are, and then we are individually setting each of those equal to 0. So let's do an example. Let me pull one up on the screen here. So something like x squared minus 4x minus 2 equals 0. So this is one of the challenging examples from yesterday. We have some negatives to deal with, but we're still going to follow our same steps. So our first and last always go in our first and last boxes. We list out, nope, sorry, I used the wrong number in there. I copied the question down wrong. So again, we list out the number that we're multiplying. So the only option here is 2 and 1. Again, we are subtracting, so 2 minus 1 gives us 1. So we know that we need to use these two numbers. Our center term is negative, which means we have to actually give the negative to the bigger number, which is 2. So 2 gets the negative, it's the bigger number. Our other one remains positive, and we get 1x and minus 2x. We do get -1 for that, so we're good, we're happy. So we've successfully factored. So we're going to replace this in blue with what we just put on the edges, and I'll highlight those in green here. So there's one edge, there's our second edge. Again, x minus 2, and then x plus 1, and then again, still equals 0. So now we need to just scroll back up and remember what we just did. We take each of these individual pieces and set them equal to 0. So again, as long as either of these this one or this one equals 0, it is a solution. Well, there's two possible solutions, so we have to solve for both of them. So let's go ahead and do that. So x minus 2 equals 0, and x plus 1 equals 0. Add 2 to both sides, we get x equals positive 2, and then subtract 1 from both sides, we get x equals negative 1. And those are the two solutions. So that's the extent of what we're working on today. You basically need to make sure, again, we're factoring, taking both of those expressions and setting them equal to 0. The only other thing to look out for, and this is just a final note for this video, is make sure that it is actually set equal to 0 before you start solving. So this rule only works if it's equal to 0. If it's equal to like 7, for example, it doesn't work. So what might happen is maybe you'll have something like x squared minus 4x minus 2 equals, in this case, let's say, I don't know, negative 3. You can't factor this until this is a 0. So basically what you need to do to solve a question like this is add 3 to both sides. You'll get x squared minus 4x plus 1 equals 0. And because this is equal to 0, now you can go through and do your factoring steps and solve. All right, so quickly to recap here, step 1, set equal to 0. Step 2, factor. Step number 3, take each of your parentheses and set each parentheses individually equal to 0 and solve. All right, thanks for watching, everybody. I'll see you in class very soon. And again, as always, questions, comments, concerns, anything, reach out, email, Teams, all of that. We are